Good morning friends, and very welcome to all of you in the series of statically determinate beam. So since from last 3 or 4 different lectures we have studied for the shear force and bending moment diagram. We are able to draw the shear force and bending moment diagram for statically determinate beam, specifically cantilever beam, simply supported beam, and some of the beam of overhanging beam. So today's session we are going ahead in the same series of a beam type, that is the overhanging beam. Before we proceed further, let us recall certain things that we studied in the previous classes. Let us recall that what we studied. So after completion of this session, we will understand the concept of shear force and bending moment, and we will be able to draw the shear force and bending moment diagram for overhanging beam. Now let us revise what is shear force and bending moment. When a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. Now, these internal quantities are referred as shear force and bending moment. Let us understood the concept of shear force and bending moment with this simple example. This is a given beam with the external loading, the loading in terms of the concentrated load, the loading in terms of uniformly varying or uniformly distributed load, and a couple which is acting at a certain point. Now if I will cut my beam into 2 parts by section XX, this line shows a section. So my beam will divide into 2 parts, left part, right part, and in that case this left part, you just visualize this left part purely. At that section, certain internal quantities will be developed. These internal quantities is referred as shear force and bending moment. And our intention in this particular lecture is to determine these 2 internal quantities. Then what is the definition of shear force? Shear force is the algebraic sum of all the vertical forces acting to the left or right of a section along the span of the beam. It is important to note down that algebraic sum of all the vertical forces at a section may be of the left or right of the section. Similarly, bending moment is the algebraic sum of all the moment of forces to the left or right of the section. Specifically important point over here is the algebraic sum of the moments. With this, let us go ahead. The sign convention which we had taken from various series lectures over here. If this is the beam, if I will cut my beam into 2 parts by section XX, then left part, if having a force of sign direction upward, or the right part having a sign direction downward, this sign convention is treated as positive shear force. Opposite to that, if this is a section, if left part subjected to the force having a downward direction, or right section having a force which is acting upward direction, this will be treated as negative shear force. About bending moment, a section is there. On the left side, if there is a clockwise moment is acting, or section right side anti-clockwise moment is acting, this moment, this bending moment is taken as positive bending moment. It is referred as sagging bending moment. Vice versa, section left anti-clockwise moment or right clockwise moment treated as negative bending moment. This is referred as hogging bending moment. Let us go ahead. Next one. Now, how we can able to determine these internal quantities? The named term of the internal quantities are shear force and bending moment. How to determine? This has been determined with the help of static equilibrium approach. Now, what is the static equilibrium approach? So, step number 1 is important for us. Find out the support reaction. And this support reactions we can find out with the help of the 3 static equilibrium conditions, like sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. The step number 2, cut the beam at a certain cross section and draw the free body diagram of one piece of the beam. What is the step number 2? I have to cut the beam at a certain cross section. Now, the decision of a cross section that has been taken care depending upon the type of the problem and the type of the loading which has been given to us. So, depending upon that, we have to take a cross sections. We have to plot the free body diagram of either left or right of the section. And then step number 3, set up the equations. For shear force, we have to take a set up the equation sigma v, and for bending moment we have to set up an equation for sigma m. Now, step number 4, solve the shear force and bending moment at that cross section. And finally, we have to plot all these points of shear force and bending moment to achieve shear force and bending moment. So, I wish you have understood already the procedure for the determination of shear force and bending moment, as well as plotting of SF and bending moment. Let us go ahead with the problem. In the last lecture, we have stopped with this particular problem. Also, we had solved, or we have drawn the shear force diagram also. The part which is remaining for the discussion is about bending moment diagram. Now, I wish you have the results of reactions. So, we have the answers for this particular beam. Let us revise the given beam, which is of overhanging beam, the beam which is projected beyond the support. So, there is the projection beyond the support over here. This is the projection beyond the support over here. So, this is to be called overhanging beam. And our next step is to find out the reactions, and we found out the reactions finally. RB, the value of RB as 80.47 kilonewton, while RA, that is the vertical reaction, is of 71.53 kilonewton, while the horizontal reaction at A at this point is 0, because there is not a single horizontal force which is acting throughout the system. So now with this, the step number 3 is the determination of shear force, and thoroughly the step how to plot the shear force diagram, which has been explained you in the previous series of lecture. So today I am not going to repeat the same thing, how to plot the shear force diagram right now, but let us recall about the relationship with the loading and the shear force diagram. This is the end part or starting point where there is no support. Loading at this point itself is 0. Yes, even though it is UDL is acting throughout the length of the beam, but at this point the shear force is 0, so the value is 0 over here. Now, this UDL is of 10 kilonewton per meter, the length of 1.2, so 10 into 1.2, 12, which is acting. If I will take a section over here, then section left down rotated is negative, and UDL, then this line which has been joined by inclined straight line. So 0 and 12 joined with the help of inclined straight line. So minus 12 plus reaction of RA, I achieve the value over here, this value. So at the reaction or at the concentrated load, my shear force diagram changes abruptly. See figure over here. Now between this point to this point there is no load. So variation of shear force which has been given by horizontal straight line. So whatever the value of shear force over here, remaining same over here, just left of 40 kilonewton. But when I will just cross this 40 kilonewton on the right hand side, then I have to take care of 40 kilonewton. So this value 59.53 minus 40, we achieve 19.53. So you just visualize over here sudden drop in the shear force diagram where there will be a point load or concentrated load. Next, this point, between this point and this point there is not a single load is there. Variation of shear force diagram which has been given by horizontal straight line. So whatever the value of shear force over here, the same value you can achieve over here. After that there is a UDL is going up till now this support. So whatever the value over here, that is the 19.53 minus 20 into 4, answers comes to be 60.47, which is the sign convention minus sign, and UDL is there, then which has been joined by inclined straight line. So 19.53 from here to 60.47 over here, I have to join by inclined straight line. Now when I will go just right of this particular support, upward reaction force which is acting over here, that is RB, so minus 60.47 plus RB, I have some value over here with the positive sign, I have to come upward over here. Then there is UDL is there, this value minus UDL multiplied by distance, the answers must come 0 over here. And this diagram which you achieve is known as shear force diagram. For us it is very much important for us to determine the position of zero shear force. That is, I am interested to find out the distance over here. So either use pure mathematics using the two similar triangle rule, find out this distance, or using the concept of shear force by taking a section, find out the distance, and this comes to be 0.98 meter. Now let us go ahead for plotting of bending moment diagram, because the part which is remaining in the previous lecture. Yes. So let us come to the tabletop. The given beam is of overhanging beam. This is UDL, point load, and from this distance onwards, once again UDL comes with us. So this values are 10 kilonewton per meter. This value is of 40 kilonewton. UDL is 20 kilonewton per meter. The distances are of 1.2114 and 1. We know the value of reaction are of RB, which is of 80.47, and RA is of 71.53, and our intention is to plot the bending moment diagram. So draw the dotted lines at important points or where the loading starts as well as load ends. We have to plot this dotted line. Baseline. All the positive values are drawn above baseline, negative values are all below the baseline. This is the basic things that we know already. Now let us give the nomenclature. If this is my A, this is B, then this is C, D, E, F, and the point G, where we found out the shear force is 0. Now next, the first point, how to find out the various values. Let us go over here on the tabletop itself. Now at C, moment at C is equal to, there is no load is acting, so moment is nothing but the force multiplied by perpendicular distance is equal to 0 itself. So this value is 0. Let us come to the point at A. MA is equal to unbalanced vertical forces. Load is of 10 into 1.2 into 1.2 by 2. This is my load and this is the perpendicular distance, and this is acting section left anti-clockwise, and this treated as negative. I obtained as 7.2. So the ordinate which I obtained over here is of 7.2. Question may arise, negative sign is already there, so it is beyond baseline. Now the question is that how to join these 2 points. The UDL is acting, so I have to join these things with the help of parabola. Simple rule, I have to join with the help of parabola. Now next, at the D point. So now moment at D point is equal to load 10 into 1.2 into bracket 1.2 by 2 plus 1. This is the moment generated because of this. 10 into 1.2 into 1.2 by 2 is the CG distance from this point, plus 1 because I have to take the moment over here. Sign convention, section left anti-clockwise negative.